would. The h index is defined as the maximum value of h such that the given researcher has published at least h papers that have each been cited at least h times. Okay, so if you published, I don't know, 8 papers, and oh, okay, there's already a example here, right? So for here in this case, we want to return the researcher's h index. So you're just looking at, like, for h1, right? I think you go like this. If h1, it is h1 is it's compliant. No, it's not. Wait. Yeah, it's compliant. Like, basically, give me one that has index more than or equals to 1. So if it were all 0, 0, 0, 0, which could be in my case right now, yeah, at least one citations. Like, yeah, it's not the case for me. I don't have any citations, so any papers. But if you have one, and if it is cited at least once, then your h is 1. But for 2, can it do? Yeah. For this and this, yeah, we can go, like, I see these are the maximum ones. But for h3, this complies, and this one complies with it, right? For h4, this doesn't, this complies, this doesn't, this complies. So we couldn't, we failed here, failed, and this is the last one that we got. So probably this is the brute force. Iterate over it, like for h equals 1, starting from there, until you see one time some value that is higher than 1, until you see 2 times that you see value higher than 2, until you see 3 times that you see a value that is higher than or equals to 3, until you see 4 times that is okay, something like that. So that's the brute force solution, which is the, what to do there. You're just, for every h, you're just going over the citations. Like, basically, you're going over your papers. I don't know how many papers do you have. We will be going over it for how much times? For depending on how good you are, right? It can, like, if you say have I mean, in the worst case, you're like very, right? It's like, yeah, number of citations you have, and is the also, it's also like the number of papers you have, and the complexity will be this time complexity. The memory, I'm not sure yet. We have to implement first. Okay, let's go. Let's go with the brute force right now. So this is the loop variables that we'll be using. This is the iterative that we will go on, and somewhere here it will fail. And then you will just return the last one because it was the last one that worked. Okay, so here you'll notice that you're at the end of it, and you'll just say if counter is less than age, I think we can double check it later on. You'll just break it. You won't go out. But else you'll just continue, right? You will just iterate the counter here by and this is another loop here that you're going to do. It will increase, you will be increasing the index. Let me just put it here. Okay, just to make, you'll be increasing the index every time you go to the next element, and your age value, you'll be just increasing the counter by 1. You will go through the whole list basically. Maybe that's okay. Maybe you can say, okay, I will be going over it, the whole list. So maybe it's, we don't have to do it maybe for citation. In citations, just go through it. If citation is bigger than or equals to age, just increase the counter. Otherwise, don't increase it. And at the end, you will check if the counter is smaller than the age index. You'll just break. But if it's equal, okay, that's perfect. And then you'll try the next one. Yeah. So for here, it will start with age will 0. It will start, counter is 0. For citations, it's 3, right? This is 3. 3 is bigger than 0, yeah, okay. Counter is increased. 0, is it bigger than or equal to 0? Yeah, it is. Increase. Yeah, it can be, you can break it probably, right? But let's not optimize it right now. It's just not the bottleneck, I think. It's the complexity will be still the same, probably. But here, is it bigger than, yeah, true, counters increase. Counter is 3 right now. This one will also work. It's 4. This one also work, 5. Okay, we got out of this for loop right now. If the counter, which is 5, is smaller than 0, no. So we continue, we increase the age to 1. Counter is 0 back again. We're going over it. For 1, yes, counter is increased. For this, no. For this, increased. So it's 4. 4 is smaller than 1. No. Continue, increase age. So this one will pass, this one increase the counter, this one will increase the counter. So counter will be 3. Is 3 is smaller than h, which is 2? No. So it will go here and h will be 3 right now. This one will increase the counter, right? It's equals or bigger, right? This one will succeed, this one will succeed, and counter will be 3. If counter is smaller than h, so if 3 is smaller than 3, no, then it will go on and it will increase the h. Later on, h will be 4, and this one and this one will succeed there. They increase the counter. Counter is 4. Counter is 2. H is 4. Yeah, it will enter here and it will break it. Then you'll just return the -1 because this was the one actually succeeded. So for 131, let's have a look. So for 131, h will be 0. We're starting, counter is 0. Citation is 1. Is it bigger than 0? Yes. Counter is increased. This one, yes. This one, yes. So this one succeeded. So h will be 1 right now. But h is 1. You will still consider, you will still go ahead. Yeah, we'll just go on. It will be identical. So let's make h is 2 right now. Is it bigger than 2? No. Or equals to no. This one, yes. This one, no. So counter is 1. Counter is 1 is smaller than 2. Yes, it will break. Yeah, so it seems to solve. Also, like there's the edge case that I was putting for h, like for the input of this, which is possible, it will go and it will say, okay, citation is 0. Is it, yeah, but at least 0 papers. Yeah, I think it's always okay-ish, but I don't know. I think it's okay. The length and these things are also not so big, so I think it could be okay. Is this something that I can optimize? Perhaps here I don't need to iterate all the time, right? If I already see something, like if counter is already if I see only once, that's okay, right? If counter is bigger than the age, just break, right? So if it's the case, it will not enter here and it will go on. A small optimization. It just makes a bit more ugly, but it's okay. Can this be even better? Like, so, right? So this four, like two loops inside there, that's going on, and you probably don't want to do this a lot. If imagine, like, yeah, if it's like very big number, what's the most it can be 1,000, and the length of it could be I don't know, 5,000 of them. So I don't know, it should be okay. It's, should I take a hint? I think no, I don't want to over optimize it right now, probably, but it will fail. But let's check. If it fails, then we know that it's not optimal. No idea, but I'm just curious right now. Let's check the hints. Sort the array first. What are the possible values of Huh. Extra space. Um, as you see, I didn't use any extra space, but um, 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 all right. It's time for the very important person. 274 H index. Oh my god, where is Neetcode? This guy. Neetcode. Unbelievable. Unbelievable.
Sort 2 video generation is not available in our region.
I don't know what I'm.
Hey guys, Greg here. Let's solve 8.
Can you give me the solution, please? Go on, go on, go on, go on. Okay, I don't want to look too much. So it's on space and on runtime complexity, I guess. I will check out the comments right now because I think I'm going to close the stream right now. Okay, I think so. It's okay. Let's leave it here. Probably on. Yeah, it's a valid path to investigate, but I gotta go. Right. Thank you, and have a nice evening, folks.